Now we're going to define the reference level of the gravitational potential energy. The person in the example carries a solid S. He carries it like this, and he is moving S like this. The solid S remains on the same horizontal level throughout its motion, while passing through points A, B, and C. The solid is neither rising up nor falling down. Then S won't lose or gain gravitational potential energy. Thus, the variation in the gravitational potential energy is zero. Note that the variation in the gravitational potential energy from A to B is equal to plus or minus mgh AB. But between A and B, the height is zero, and as a result, the variation is zero. That is to say, the gravitational potential energy at B minus the gravitational potential energy at A is zero. We obtain that the gravitational potential energy at B is equal to the gravitational potential energy at A. Also, we can prove that it is equal to the gravitational potential energy at C. The gravitational potential energy of a body that moves on the same horizontal level is always constant. It doesn't change. So what is the reference level of the gravitational potential energy? It is the horizontal plane where the gravitational potential energy is equal to zero. If we take the red horizontal level as a reference level for the gravitational potential energy, the gravitational potential energy at this level is zero. Then, the gravitational potential energy at A is zero, the gravitational potential energy at B is zero, and so that at C. This is the reference level of the gravitational potential energy. Let's define the reference level of the gravitational potential energy. It is a horizontal plane where the gravitational potential energy is equal to zero. Now to determine the expression of the gravitational potential energy at a point, then determine the expression of the variation in the gravitational potential energy between 2 points. Consider the following example. The solid S moves from point A to point B. Point B is at a height hb above A. Then in another situation, from point A to point C, that is at a height hc below A. Note that A is found on the horizontal plane that is taken as a reference level for the gravitational potential energy. That is to say, the gravitational potential energy at A is zero. GPE at A is zero. Now, during the rise of the body from A to B, the variation in its gravitational potential energy from A to B is equal to plus mg times the height between A and B, which is hb. Then GPE B minus GPE A equals to plus mghb. But GPE at A is zero since A belongs to the reference level of the gravitational potential energy. We obtain that the gravitational potential energy at B is equal to plus mghb. This is in the first conclusion. In the second situation where the body descends from A to C, the variation in the gravitational potential energy from A to C is equal to minus mg times the height between A and C. And as a result, GPEC minus GPEA equals to minus mghc. GPE at A is zero since the reference level of the gravitational potential energy passes through A. So GPE at C is equal to minus mghc. The gravitational potential energy at B is plus mghb. The gravitational potential energy at C is minus mghc. We notice that the gravitational potential energy takes into account the position of the point relative to the reference level. When B is above the reference level, the gravitational potential energy of the body is plus mghb. When C is below the reference level, the gravitational potential energy of the body at C is minus mghc. All energies, including the gravitational potential energy, are expressed in joules in the SI. Consider the following application. The cart of mass 100 kilograms moves on a track ABCD. The reference level of the gravitational potential energy passes through point C. So the gravitational potential energy at C is 0. This is the ground level passing through point B. A is at 15 meters, C is at 10 meters above the ground, and D is at 6 meters above the ground. The question is, calculate the gravitational potential energy of the system C Earth at A, B, C, and D. The gravitational potential energy at A. Point A is above the reference level. Then the gravitational potential energy at A is plus mgha. Keep in mind that the gravitational potential energy at a point depends on the position of this point relative to the reference level. The height of A is calculated from the reference level and not from the ground. So this is the height of A. It is equal to 15 minus 6. 100 times 10 times 15 minus 6. The answer is 5,000 joules. Now for the gravitational potential energy at B. Point B is below the reference level. That is to say, the gravitational potential energy at B should be expressed as minus mg hb. The height of B, hb, is measured from the reference level. So this is the height of point B, which is equal to 10 meters. Minus 100 times 10 times 10 minus 10,000 joules. Now for the gravitational potential energy at C. It is equal to 0, since C lies on the reference level of the gravitational potential energy. Now for the gravitational potential energy at D. D is below the reference level. So minus mghd minus 100 multiplied by 10 multiplied by the height hd from the reference level is here. So hd is equal to 10 minus 6. 10 minus 6, and this is minus 4,000 joules.